Hi, this is Mr. Warden. This is a video key for Do Now number 16.3 for geometry. I'm introducing some concepts about isosceles triangles in this Do Now. The first question asks you to prove if angle B in this triangle is congruent to angles, that angle B is congruent to angle C. And we have been given that AB is congruent to AC. Now, the easiest way to do this is going to be to prove that triangle ABC is congruent to triangle ACB, because then you can use the reflexive property for BC. So we'll start with the givens, okay, and let's label the things we know from the givens. We know this and this are congruent. We can then work out a few other things. We can then say that angle A is congruent to itself by reflexive. Okay, and with that, we now have a side angle side thing we could do. We could also have taken a different, we could say BC is congruent to BC by, I'm going to call that CB to emphasize that I'm going to flip that by reflexive as well. And then we can say triangle ABC is congruent to triangle ACB by, we could either use side angle, I'm going to go ahead and label this. So make this angle congruent. I'll put a little mark on it, okay? And then we can also, I'll change the color for that. We can say that this side is congruent to itself. So now we have enough information. We could say by side, 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 or we could say by angle, side, angle, or side, angle, side. So side, angle, side could allow us to prove the two versions of the triangle are congruent. And also we could prove by sides, side, side, side. Now, side, angle, side is probably a little better for us for what we need, but it works either way. Okay, so we can prove that triangle ABC is congruent to ACB by side, angle, side, or by side, side, side. Okay, so if that's true, then angle B and angle C are corresponding angles to each other, which by Kappa-Kadika, angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. Okay, I'm just going to make a note. This isn't necessarily part of the proof, but this helps you with your thinking about it. Angle B and angle C are now corresponding parts of congruent triangles when we consider the triangles as being congruent as being ABC and ACB. So we can now prove that those two angles are congruent. That angle and that angle, those angles are now congruent according to that. Okay, let's take a look at what it says here. So what you've just done is, what we've just done is proven theorem 19. If two sides of a triangle are congruent, then the base angles opposite them are congruent. Okay, and there's some specific language here. So these sides being the sides that are congruent, the base angles that are opposite, so angle C is opposite of AB, and angle B is opposite of BC. And by having these two sides being congruent, we treat this as the base. This is a base angle that's opposite to AC, and this C is a base angle that's opposite to AB. So that's what it means. If two triangles are congruent, and here's a little diagram, you see a little mark here, a little mark there, those sides are congruent, and these angles are the base angles that are opposite to them, and those are congruent as well. All right, number 2 is going in the other direction. We know that these angles are congruent, so let's label them. That's a given. We've been given that this angle is congruent to this angle, and we want to prove that DF and EF are congruent. Okay, so after the givens, Okay. We can say that angle F is congruent to itself by reflexive. We can say that DE is congruent to ED by reflexive as well. Okay, so let's label the stuff that we now have. I'm going to color code it. So I now have established that angle F is congruent to itself and side DE is congruent to side ED. Okay, at this point, I mean, I've got angle, but that doesn't prove congruency, but angle, side, angle does. So now I can say, and so that means, what that tells me in a way is I didn't need to prove that angle F was. So that's sort of an extra thing. We didn't need that. So we can say triangle FDE is congruent to triangle FED. So this is triangle FDE. This is triangle FED. And what we can use is by angle, side, angle. Okay, and once we have established that, I'm just going to note that that EF, okay, I could relabel these triangles. So EF, which is the same as FE, and DF are both congruent, or sorry, are corresponding parts. So I'm just going to note that EF and DF are corresponding parts of these now established congruent triangles. So scroll down a little bit. Okay, so we can now say that DF is congruent to EF by kappa kata ka. Corresponding parts of congruent triangles are congruent. And this proves theorem 20. If base angles of a triangle are congruent, the legs opposite of them are congruent. And now you might notice that theorem 19 and theorem 20 are reverse versions of each other. Let's take a look here at number 3. Okay, so I've given you a hint that reflexive property is probably your friend, and if you could prove triangle ABC is congruent to triangle CBA, ABC, CBA, then and kappa kata ka will all play a role. So that would all be useful. So we have been given that AB and BC are congruent. So let's start working through this. So givens, okay, and then after the givens, we start looking at things. So if I've got two sides, probably the most useful thing would be this angle. I mean, I could also prove that this side is congruent to itself, but I think for flipping the triangle very specifically, proving that B is congruent to itself. So angle B is congruent to angle B, okay, by reflexive. Okay, and once I've proven that angle B is congruent to itself, which I'll mark up here, okay, once I've done that, now I can prove that triangle ABC is congruent to triangle CBA, okay, by angle side angle. I'm sorry, that's not right. That should be side angle side. Yeah, so this is a side, that's an angle, that's a side. Okay, so now that I've proven that, I will note that let's see, we're going to call them angle BAC and angle, this is BAC, because if I just labeled it A, that's ambiguous. So I also have, and BCA, angle BCA are corresponding parts of congruent triangles. Now, all along, I've been trying to prove angle 1 and angle 2 are congruent. And my goal, to do that, I kind of need to prove that these angles are congruent, because then I can use vertical angles. Vertical angles of congruent angles will be congruent. Okay, so now I can say that angle BAC is congruent to angle BCA. Let me scroll down so you can see what the heck I'm doing there. Okay, and I can prove that by kappa kata. Okay, corresponding parts of congruent triangles are congruent. So let's label those congruent parts. So those angles are congruent. And I'll scroll down a hair so you can see the whole triangle. And at this point, I can say that angle 1 is congruent to angle 2 because vertical angles of congruent angles are congruent. That's a theorem way back from 2.8. Okay, and then we're done. All right, I hope that helped.